everybody, it's Mrs. Gano. Welcome back to Chemistry in My Kitchen. Today we're doing a lab called the Bell Jar and Vacuum Pump Lab. This is an awesome set of equipment and it's just a super cool lab. So before we start, I need to highlight the shirt I'm wearing, of course, because we're doing science. So I'm wearing my shirt, being filmed by my very favorite Adam. All right, so this is the worksheet that goes. I'm gonna post this worksheet along with the lab. And so we're gonna just go step by step through here and see what's going on. So there's some cool stuff in the box. So first of all, we have this bell jar, and this is the bottom plate that goes on it, okay? There's a syringe. There's no markings on it because we're not doing anything qualitative. This is just, or we're not doing quantitative, just qualitative. So I'm just gonna be sucking in air and pushing out air. And then we've got some tubing that's connected, and the tubing has got a special valve in it. These valves are one-way valves, so air can only go in this direction. And same thing here, air can only go in this direction, in the direction of the arrow. Okay, so these things all twist on, so I'm gonna twist this on here to the top. That's connected. And then I'm gonna connect the syringe right here with the twist, like that, all right? And so the very first thing is we're gonna put this on here, okay? And then it says, what's inside the bell jar right now? That's the first question. What's inside the bell jar? So the answer is obviously air. There's air inside the bell jar, okay? So now, this is usually a two-person thing, so I'm gonna try to do this by myself. I'm gonna pull out here, so air is getting sucked into the syringe, and then I'm gonna push out. I don't know if you guys can hear that, I'm gonna do it again. Okay, and you can hear air, and it's getting pushed out right here. You can hear it. Unfortunately, there's nothing to see, but hopefully you can hear it. And now, look, the bottom of the bell jar is stuck onto the top, right? And so I can keep doing this. You can hear the air coming out. And this is getting successively harder and harder to do. And my syringe isn't pulling out as far. It's taking much, much more effort. It's getting pushed in by itself. And when I squeeze out, there's less and less sound, which means there's less and less air because I've pulled all the air out of the bell jar now. I've pulled it out. It's gone this way. It gets pulled into the syringe, and then when I push back down, it gets pushed out this way because of the one-way valves. And so really what I've done is I've sucked all the air out of the bell jar. All of the air, probably not all of it, but a lot of it, okay? So what we have in here is technically called a vacuum, a lack of air. And so the reason that this is getting more and more difficult to pull is because there's no air here pushing my syringe out, and I'm pulling against the force of air pressure on the outside. Okay, so now I'm gonna undo this and listen very carefully. Do you hear that? And now this falls off because air went rushing back in here, and now there's air pushing inside and it pushes the plate off. Okay, so this just shows you the difference between lack of air and air pressure. Why was the plate stuck on here? Because air from the outside was pushing it on and keeping it on. There was no air on the inside pushing it down. Okay, so that's the very beginning part there. The next part of this is to weigh it on a balance, okay? So we're gonna do that again. We are gonna pause the video momentarily while I go get a balance. And we're back with a balance. Okay. So now I'm gonna do that same experiment. Again, connected that, set this on here. We're gonna pull air, you can hear it, out as much as I can. Now it says to do this 24 times. That is really, really hard. You can't hear the air coming out anymore. Okay, so I'm gonna disconnect right here. All right, so that now this is kind of locked in place. And we're gonna weigh this. 110.02 grams, okay? And now I'm gonna do this again. I'm gonna disconnect this, listen carefully. Hear that? And then we're going to reconnect it. And now we're going to weigh it. 110.24 grams. That difference in mass is the amount of air that rushed back in. So I had removed that amount of air from the bell jar, and now the air rushed back in and it weighs more because there's air inside where there wasn't before. So we can see the mass of air that I've removed. Okay, so now we're going to experiment with some fun stuff in the bell jar. All right, we're going to put a balloon in. So this balloon is already tied, and you can see that it's a really small size. There is a little bit of air in that balloon, but not much. And the air that's in the balloon is pushing out in all directions, but the air that's outside the balloon is pushing down in all directions, and it's pushing harder, and so the balloon is pretty small. So we're going to put it in the bell jar like that. I'm going to connect the tubing, and we're going to remove air from the bell jar again. Okay, same thing. Oop. This is why it's a two-person lab. Okay, there we go. What is happening to that balloon? Oop, there it goes. And this is getting really hard to pull out. And of course, it's not helping that the balloon is stuck to the valve there. But you can see that every time that I pull the syringe out, the balloon is growing a little bit. The amount of air inside the balloon isn't changing at all. It's the amount of air outside the balloon that's pushing on it that's changing, right? And so now the pressure inside the balloon is greater than the pressure outside the balloon. And so the balloon has expanded. What happens when I open this valve? Okay, so I'm gonna open it. Try to keep my hands out of the way. There it goes, back to where it was. Okay, so that is an example of the effect of pressure and volume. Let's do another one. This time I'm gonna use a little bubble. So this is a bubble from Bubble Wrap. Okay, let's try this. Also, I want you to notice that, of course, the bottom is stuck onto the plate again. Bubble is doing the same thing as the balloon, and if I can get enough air out, maybe I can get it to pop. This is my exercise for today, by the way. This is pulling the syringe, like my arm exercises. Is it gonna pop? I don't know. Doesn't look like it. Whew, I can't pull any more air out. All right, so now what happens when I open the valve? Oh, there it goes. And now you can see that it's actually popped, that the air did get pulled out of it. It was just in such a large shape that we couldn't tell that it had popped, but it really actually popped. Okay, another object in there. We're gonna use a PEEP. So I actually walked to CVS the other day to get PEEPs. Oh my goodness, this is big. All right, let's put it in there. Gross. Connect this. All right, what do you guys think is gonna happen when I remove, oh, try this again. Yeah, maybe you can put your finger on it. Okay, there we go. There we go. Okay, you can let go now. Now that's stuck on the bottom. Woo! Look at the PEEP. Why is this happening? What is in marshmallow after all? Except for sugar and air. Now how come you can see it's expanding a tiny bit and now it's not expanding anymore? Why is that? It's because I've pulled all the air that was in it out. It's as big as it's gonna get because I've gotten all the air out of that PEEP. What's gonna happen when I open the valve? Same as before. No, poor PEEP. And look at it. Now all the air has been removed, and then when I put air back in, the pressure pushed it back down, and there's no air in there to fluff it up and to keep it its original size. You can see the difference there in the PEEP. Rip PEEP. All right, now I've got sugar everywhere. Okay, one more item in there. This is shaving cream. Put a little bit of shaving cream in here. Uh-oh. There we go. I've got sugar all over the countertop. Okay, screwed that on there. Ah! Disaster. All right, let's try that again. Can you put your finger on there for me? Let me wipe this off. Okay, let's try again. There we go. Okay, I think you can let go. You can see the shaving cream expanding. Let's see how much bigger I can get it to go. Oh, expanding. I think that's about it. Whew. All right, what's gonna happen when we open the valve again? So again, air comes rushing back in, and there's nothing to support it. There's no air left in the shaving cream, and so it just basically explodes. All right, so we're gonna rinse this off. I'm gonna pause the video for a second, rinse this off, and come back, right back. And we're back. Okay, one more that I had forgotten to do that's on the sheet is the suction cup. So you guys know how suction cups work. You put it down and you push, and it sticks to a surface, right? Like this. Okay, so I'm gonna do that here. I'm gonna stick it to, oops, stick it to the bottom plate, okay? And then we're gonna do the same thing with the syringe. Pulling air out of the vacuum jar. So you can see that the bottom plate is stuck on there. I think you can see the suction cup changing. And let's see. Ooh, not much air left in there. There it goes. It fell off. Why did it fall off? It's because there's nothing pushing the suction cup down. There was more air left underneath the suction cup than there was pushing down on top of it. And so it came off, all right? So again, I let air in. It's not gonna re-stick it because it's not there. So why does a suction cup work just on a regular table? When I push down on a suction cup, I'm pushing the air out from underneath it, and so there's very little air underneath it and a whole bunch of air on top of it pushing it down. All right, last demo for this one is really, really cool. This is my favorite part of this, is we're gonna boil water at room temperature. So I've got a little tiny plastic cup here, and I've got warm water in my sink, so I'm gonna get some warm water. Just like that. I'm gonna bring it back here. And we're gonna connect this again. Okay, I'm gonna pull air out. Now this one takes a little bit to get going. Okay, So let's look at the water that's in there, in that little cup, and see if you can see anything happening. Oh, I see it. Can you see bubbles forming in the water right there? You see those bubbles? That's boiling. That is water boiling at room temperature. Well, it's a tiny bit warmer than room temperature, but that's literally boiling. And this is because the pressure of the water vapor inside the liquid is now equal to the vapor pressure pushing down on the liquid. This is a super complicated topic, that I will explain to you guys again. But those bubbles in there, that's the beginning of boiling. Now, I really can't pull any more air out of this. It is pretty dang hard. But that's what we got going on there. Okay, and so those bubbles there is boiling water. What's gonna happen when I open the valve again? Air's gonna come rushing in. We'll watch and see what happens. Okay, so this time it didn't splash all over the place. And what's the temperature of this water? It's still just warm. It's the same temperature as it was before. It's not boiling hot. It's not boiling because it was hot. It is boiling because of the lack of pressure on top of it. So, super, super cool example of how pressure affects things that go on. All right, so those are all the activities in this packet. Follow along, see if you can answer some questions, and send me the questions on the discussion group so we can talk about it later. All right, thanks a lot. See you guys next time.